Good morning, good afternoon. This is the last lesson in Unit 1 for Algebra 2 and will include some material that I believe is new for most, if not all of you. We're going to be talking about absolute inequalities in this lesson. So when we're talking about inequalities, of course, we're talking about like the less than or equal to, greater than or equal to. And we covered linear inequalities a couple of lessons ago, and now we want to apply that to absolute value types of relationships. This is probably one of the most challenging things that we will cover in Algebra 2. So if you find it difficult, you're worried about whether the next lesson or Unit 2 is going to be even harder, probably not. Like, we don't necessarily go from the easiest material to the hardest material. It is sprinkled throughout the course. So let's take a look at an example problem. And we want to talk our way through this, reason through it. So if I were to read this out loud, I would read it as the absolute value of 2x minus 1 is less than 5. Now, in order to reason our way through this, I'm going to do some work off to the side here and just kind of like talk through it. What does this mean? What does it look like on the number line? How can I make sense of this problem? Remember that the definition of absolute value is distance from 0. So what we're talking about here is the distance from 0 on that number line is less than 5. Okay, and what I'm doing there is I'm just engaging the definition of absolute value. We defined absolute value last class as the distance from 0 on the number line. So when I see the absolute value symbols, that's how I want to interpret it. The distance from 0 is less than 5. So what does that look like? What kinds of numbers would that be? If this is my number line and I put the 0 in the middle, I can count that distance in either direction, to the right or to the left, and whatever that distance is from 0 has to be less than 5 units away. So to the right, I have a positive 5, and this would mark the distance that is 5 away. So distances less than 5 would be anywhere in between the 0 and the 5. Going to the left, and remember, distances, it can be measured in either direction. So the negative 5 is also 5 units away from 0, and anything in between the 0 and the negative 5 would have a distance from 0 less than 5. So what we're looking at here are all of the numbers in between the negative 5 and the 5, but not including the negative 5 and the 5, because it doesn't say the distance can be equal to 5. It says it has to be less than 5. And so I really want you to pay attention to the reasoning there. If you're watching this video on your own or you're rewatching it from home and you need to rewind it a little bit and listen to that explanation again, please do, because I want the reasoning here to make sense to you. About the distance from 0 is less than 5. Now, the distance from 0 of what? Well, whatever is in the absolute value, which in this case is a 2x minus 1. So it's the 2x minus 1 that has to be wedged in between the negative 5 and the 5. We did a lesson on inequalities, and then we talked about these things called compound inequalities. If I have something and it's in between negative 5 and 5, I can write that as a compound inequality. So negative 5 is less than 2x minus 1 is less than 5. And what I want you to notice here is how the inequality statement actually mirrors what we have on the number line. It makes the number line a very useful tool for picturing how this inequality looks. Once we have that inequality written, then we are able to go ahead and solve it. And we've already covered solving compound inequalities. I want to get that x by itself. It's being multiplied by 2, and we're subtracting a 1. I will start this by adding 1. And remember that we need to add it to all 3 parts in order to make sure that the inequality stays like balanced the way that it was. Negative 5 plus 1 is negative 4. is less than. -1 plus 1 right here is 0, okay, and that's why it drops out. So I'm left with the 2x, and then 5 plus 1 is 6. And then I want to undo that multiplication in between the 2 and the x, and I will do that by dividing by 2. I am dividing by a positive 2, so there is no need to flip the inequality in this problem. So -4 divided by 2 is -2. 2 divided by 2, of course, is 1, leaving me with 1x, which I don't need to write that one. And 6 divided by 2 is 3. And this would be your final answer right here. So there's, oh, here we go. So there's your final answer. -2 is less than x is less than 3. Now there are some other ways of writing that answer, and the most common way is something called interval notation. If you were doing Algebra 2 honors, they would take you through the interval notation. If you try to do this problem on PhotoMath, it will probably give you an answer in interval notation. So if you are using PhotoMath as an aid in doing your math work, make sure that it's making sense to you. There are ways to use those tools to help you learn. But if you find that you are copying stuff and it makes no sense to you, please ask a question. In that case, you're not doing learning and it's not helping you learn the material. So don't be writing answers using symbols and notation that you've never seen before and don't know what they mean. Ask a question. That's why I'm here. And I can explain the interval notation to you as well if that is something that you would like to do. Okay, let's take a look at our next example. So this example is the absolute value of 2x plus 4 is greater than or equal to 6. When you're saying it in your head, make sure you're saying it correctly. And what we're going to do again is interpret what we're looking at here in terms of the definition of absolute value. So absolute value means distance from 0, and in this case we're talking about the distance from 0 is greater than or equal to 6. So I'm going to go ahead and write that out here. Distance from 0 is greater than or equal to 6. So what does that mean? Let's take a moment, look at the definition, and then use the number line to help us picture what that is. Here's my number line. Here's 0. If we're talking about a distance from 0 that is greater than or equal to 6, well, here's the 6, so that would be a distance equal to 6. If the distance is greater than 6, I plunked my ruler down, I'd be looking at points further away from 0. So I'd be looking at these points out here, including the 6, because it did say equal to 6. But distance can work in either direction, and so we have going out to the left, this would be a distance equal to 6. And then if the distance is greater than 6, it means that I'm pushing further to the left. And that is the sticking point on absolute value inequalities, is because when we're dealing with a number line, greater than always means to the right, unless we're talking about distance. In this case, the distance is actually becoming greater as I move further to the left. So if I were to pick, like, say, -7, even though -7 is less than -6, okay, take a second, make sure that makes sense to you. If I were to put a ruler down and measure the distance from -7 to 0, it would be 7 units away, and 7 is greater than 6 in terms of the absolute value. That is a bit of a sticking point in terms of like how we think of the number line and how we think of greater than and less than. So again, take a moment if you need to, if you're watching this at home or rewatching it after we've gone over it in class, and rewind that and let yourself digest how we picture that and how we think about it. So what the absolute value or the distance from 0 of what? Well, 2x plus 4. So that means the 2x plus 4 is either in this section, or 2x plus 4 is over in this section. It can be in one or the other, but not both. A number is either less than -6 or it's greater than 6. It's one or the other, but not both. So when we write this, it will become a compound inequality in 2 parts. We can have 2x plus 4 is less than or equal to negative 6, or 2x plus 4 is greater than or equal to positive 6. And again, this is kind of weird because we're talking about a greater than inequality, and then we're shading in something that's actually less than, and that's that transition from the absolute value over to how we would express that on the number line. So when you split this inequality, you end up with a less than inequality going to the left, and you end up with a greater than inequality that goes to the right. Once you have those inequalities, now it becomes a problem like what we did a couple lessons ago, where you're solving your compound inequalities. And you can actually solve these side by side. They're going to solve the same way, but you are going to get different answers for them. So if I want to isolate the x, I subtract 4. 4 minus 4 is 0, leaving me with the 2x. Be careful with your signed numbers, and hopefully even take a moment right now and think, what's negative 6 minus 4? Picture something in your head. Hopefully you're picturing negative 10. If you're picturing something else other than a negative 10, I want you to make a little mental note that operating with the signed numbers might be an area where you're making mistakes. You are allowed to use a calculator in Algebra 2. So use a calculator if you are aware that you tend to make mistakes like this. Then to finish the problem, we would divide both sides by 2. And we get x is less than or equal to negative 5. And then we would work the same algebra over here in the other problem. So 4 minus 4 is again 0. 6 minus 4 is 2. And divide both sides by 2. And we get x is greater than or equal to 1. Common mistake, and that would be the end. You might want to put the or in between. Like, it can be one or the other. A number can be less than or equal to negative 5, or it can be greater than or equal to 1. But there's no number that would be both of those. Common mistakes that students make. Let's talk about that for a moment. Here are some common mistakes that students will make. Probably the most common mistake is not isolating the absolute value first. Okay, that is probably the most common mistake students make, is they just see an absolute value equation and they'll try to split it up into 2 equations or 2 inequalities before they've isolated the absolute value. So check your work, make sure that you're getting that absolute value by itself before you're doing anything else with it. Another one is simply ignoring the absolute value. So being in a bit of a state of denial about the fact that it is an absolute value problem and just treating it like there are no absolute values there. And then the other thing that students will do is they don't quite ignore the absolute value, but they kind of temporarily ignore the absolute value. So what they'll try to do is solve by ignoring the absolute value and then like adding in another answer at the end, adding in another answer like at the end. I'll explain what I mean by that. So students will do something like this. They'll have the absolute value of x plus 1 is greater than 4. Okay, and so they will ignore it, like, okay, they'll just pretend it's not there, okay? Then they'll solve it, and they'll get x is greater than 3, and then they will just toss in x is less than, or not that equal to, this one didn't, x is less than negative 3. Even though there's no work at all to support where this came from, like they just took the 3 and they just like threw in a negative 3 at the end. And it's kind of this avoidance. It's showing that the student's aware that there should be more than one answer to this, but they don't know how to get it. So just because I don't want to leave that with anybody writing that down or remembering this, I do want to make sure that I fix what I did wrong in this problem. So the correct way to do this, just so we are clear on the correct way to do this problem, is you would picture this as the distance from 0 is greater than 4. And numbers can be, the distance can be greater than 4 if you are over here on the right. So like numbers like 5, 6, 7, 8, and so forth, they would be further away from 0. And then on the left, you would have to push, again, further away from the 0. And so you would have less than -4. So the way this would split up is x plus 1 is either less than -4 or x plus 1 is greater than 4. And then you would solve each one by subtracting the 1. I want you to notice something. If the way that I had done it out before, the incorrect way, where the student pretends that there is an absolute value and then they throw something in, they actually will get half of the problem correct, but the other half of the problem isn't x is less than -3. It's actually x is less than -5. And in order to get full credit, you do have to get both answers, and you have to get them both correct. So what we're going to do right now is do a practice problem. So if we're doing this like in class, when we're doing it either virtually or face-to-face, whatever day we end up doing this. What I'm going to do is I want you to stop the video right here, or I'll stop playing the video right here, and we're going to work it out and we're going to talk it out. So this would be the end of the video. So if you're doing this in class, stop the video right here and well, actually, let me give you the practice problem. Okay, so the practice problem is the absolute value of 2x plus 2, close the absolute value, minus 5, which is outside the absolute value, is less than 15. So I want you to write that problem down, and we're going to work it out. Take about 5 minutes to work it out. Some of you will do it faster than that. Some of you might not quite finish in 5 minutes. And then we're going to talk it through and go over it together as a group. And that would be the end of the video. I am going to do a nice long pause and finish out the problem in the video for those of you that are making it up afterwards or want to see an explanation of it as you're studying for your test. Otherwise, we are done with the video. Okay, for those of you that are watching for study purposes or because you missed class and you missed the explanation that happened in class, remember that the first mistake that I said, common mistakes that students make, is they don't isolate the absolute value. So I'm going to just circle the absolute value here. There's the absolute value. That's what you need to have isolated. You need to have that by itself before you do anything else. So I have a minus 5 out here, and we don't want that minus 5. So we go and ask ourselves, how do I undo minusing 5? And hopefully your answer to that is you would add 5. So the first step for this is actually to add 5 to both sides of the inequality. That's going to give us the absolute value of 2x plus 2. Negative 5 plus 5, of course, is 0, and that's why it drops out. And then we bring down 15 plus 5 is 20. Now we can split it up. Okay, we can't do it with the 15. It doesn't work. It only gives you half the problem. So remember, the thinking here is the distance from 0 is less than 20. So you don't have to do a number line, but the number line is a tool that you can use to picture what values or what your inequality should look like. If the distance from 0 is less than 20, then you're talking about numbers that are closer to 0 than 20 is. So you're talking about this middle chunk. And what is in that middle chunk? Well, 2x plus 2 is. So when I go to write my inequality, it's going to look like negative 20 is greater than 2x plus 2 is less than 2x plus 2 is less than 20. So this becomes negative 20 is less than 2x plus 2 is less than 20. I'm going to subtract 2 from all pieces of that. So negative 22 is less than 2x is less than 18. and then I will divide everything by 2 to get negative 11 is less than x is less than 9, or x is some number in between negative 11 and 9. And that's a wrap on this. So there'll be some kind of homework assignment to go with this, and then we're going to, I think I have a catch-up day in there because we kind of fell behind on the inequalities, so I gave us a day to breathe and to catch up on stuff, and we'll have a review day, and then we will have a test forthcoming.